Now that we spent a lot of time with ionic compounds, it's time to take a look at covalent compounds. So we know that ionic compounds was that transfer of electrons. And the difference between covalent compounds is that now we're going to be back to dealing with neutral atoms. There's no more ions involved. And we're going to be dealing with the sharing of electrons instead of transfer. So this is important, and the fundamental idea of covalent bonds is that you are sharing electrons. Valence means kind of your outside, and co means shared, so you're sharing the outside of your electrons in a covalent bond. When you're sharing these electrons, when you're doing this process, mainly you're going to find atoms that tend to become anions, and that's because becoming an anion is gaining electrons. And sharing is a way that when you share, you lose a little bit, but you gain a little bit. And so these are going to be all non-metals that form covalent bonds. This is a property of non-metals, right? Metals only form cations. Non-metals are the only things that participate in covalent bonds. When we form covalent bonds, we're sharing electrons. And not only that, but we're sharing pairs of electrons. So if we look, for example, at this top one, you say you have two hydrogen atoms. They now are linked by sharing a pair of electrons. In the case of, say, two fluorine atoms, they are sharing a pair of electrons. And so we can see that's a case where you have two atoms coming together to form a molecule. They're held together in that molecule. And so it is particular atoms sharing electrons with other particular atoms. This is distinct from ionic bonds where you just had kind of transfer and then they were all together positive and negative. But here we can see there's explicitly, in this case, the carbon is sharing a pair of electrons with that fluorine atom, pair of electrons with that fluorine atom, that fluorine atom, and that fluorine atom. And so covalent molecules are going to have a much more rich structure to them, and that's why they have structural formulas. Ionic compounds have beautiful, beautiful structures, but you just kind of get that repeating pattern over and over again. Whereas with molecules, you're dealing with a coherent single package that we call a molecule. So covalent compounds are oftentimes also called molecular compounds because they're the ones that have molecules. And we can see this representation over here with all the atoms is a bit more simplified in this structural representation where you have lines between all of the atoms signifying that sharing of a pair. That the fluorine atoms, you'll note, are not linked to each other. They're all linked through the carbon atom. So when we're dealing with molecular formulas, we have that end of the molecule, right? There's a coherent, these are all the atoms in the molecule. So when we're dealing with covalent compounds, it's no longer a ratio. It is a comprehensive list of all atoms in that molecule. So N2O is two nitrogen atoms, the blue spheres, and one oxygen, the red sphere. NO2, one nitrogen, two oxygens. N2O4, two nitrogens, four oxygens. So a couple of things that come from this is first, we can form more than one molecule between the same pair of atoms. So nitrogen and oxygen form these three molecules at least, and many others. One of the things that affects that is when it comes to covalent compounds, you can't predict a single formula, right? We did an example with ionic compounds of aluminum and sulfur. What compound do they form? When you're dealing with covalent compounds, if you said nitrogen and oxygen, what compound doesn't form? You don't know. You cannot make that prediction because here's three possibilities right here. You can kind of mix them in different ways to prefer one or the other, but all of these are possible. So covalent compounds are a lot more complicated than ionic compounds because you have what ratios do you have? How do they all come together? How are all the atoms fitting together? Along those lines, ratios should not be simplified. If we see NO2 is the same ratio as N2O4. One of those is a brown gas, one's a colorless gas. Those are different compounds with different properties. As a result, we should not simplify N2O4. We leave it as N2O4. So really, when it comes down to it, covalent compounds are a lot more complicated in terms of how they come together and their properties than ionic compounds. So ionic compounds, we're basically done. We have described all the aspects of ionic compounds. Covalent compounds, this is all we're going to do right here because they're going to get an entire chapter later on in the semester. So chapter 7 is all about forming covalent compounds, and we're still only going to scratch the surface. There's a wide variety. If you take organic chemistry, that is a whole year about how to form a variety of organic compounds and things that they do, of covalent compounds and things that they do, and all sorts of world beyond that. A lot of rich chemistry in this. Because it's hard to predict, right? You got to make stuff and see what it does.